Welcome and thank you for joining us today. My name is Sagar, and I work as a product engineer in the real-time GIS dev team in Redlands, and I'm joined by my colleague.
Good morning, my name is Josh Jorney. I'm the product manager on the GeoEvent Server team.
Over the next hour, we'll introduce some of the key real-time GIS capabilities of ArcGIS. Just out of curiosity, just by the show of hands, how many of you are using real-time GIS or maybe GeoEvent for that matter? So it looks maybe a quarter or a third of the crowd is using GIS, real-time GIS. So let's take a look at the agenda. Over the next hour, we'll be focusing on these 5 points. What is real-time GIS? How do you work with real-time data? Applying real-time analytics and visualizing real-time data. And towards the end, we'll be wrapping up and summarizing the session. So let's take a step back and explore what is real-time GIS. The real-time GIS capabilities of ArcGIS satisfy the 3 challenges that I've highlighted in the screen. The first is ingesting high volume, high velocity real-time data into ArcGIS. So it can be data coming from your social media like the Twitter or the Instagram feed or maybe the RSS feed. You can connect to your in-vehicle GPS devices. We can also connect to a wide variety of sensors from different field sources, or maybe field crew for that matter. In certain cases, it can be a field crew on an oil rig. So let's say for an example, in case of an emergency situation, the field crew may press some panic button and it may alert the appropriate emergency department. Performing real-time processing and analysis on the data as you receive it is a second step. This involves filtering, enriching, and detecting patterns of interest. Filtering may be attribute filtering or spatial filtering. So let's say if you want to view only certain type of data, you need to perform filtering. In second example, maybe if data is coming from different sources, one of them is dynamic source, and the second is a static table. And if you want to combine that data, you need to perform enriching. Detecting patterns of interest may be the third case. For example, if you are interested in monitoring a vehicle if it enters a specific dangerous zone or a specific zone. Sending alerts and updates to those who need it and when they need it, whether that's adding or updating existing features and sending emails, or maybe writing that event data to the spatiotemporal big data store. With the spatiotemporal big data store, it allows the users to view data in an aggregated format, or you can also view the discrete features. Real-time GIS is no longer on the server side. It now extends its capabilities on the web, so which includes a portal for ArcGIS and ArcGIS Online. We'll explore those capabilities a bit later. First, I would like to set up a context. The data that has fueled GIS in the past was typically created for that particular moment. So that includes data of what has happened and is happening or what will happen in future. So while the data has proved valuable for that particular moment, the current snapshot of what has happened is out of date immediately. Especially in today's fast-paced and constantly changing world, the current snapshot is outdated immediately as soon as it is created. So what is real-time GIS? It is basically continuous stream of live data coming from different variety of sensors or maybe data feeds. There are a wide variety of agencies. For example, law enforcement agency may want to look status of their assets in the field. It can be in-vehicle GPS constantly sending telematic information to the control center, or it can be a GPS location of a police officer when he's trying to communicate to the control center. Utility companies may want to visually represent the live status of their network with the information captured by the sensors in the field. While these sensors don't move, their status can update and change very rapidly. This needs to be sent to the control center. RFID is used in wide variety of sources for tracking items of interest. For example, warehouses use RFID for inventory management. or operations department may use RFID for ensuring that their product or device passes through all the designated stages. There's a wealth of volunteer geographic information that can be leveraged for situational awareness. Here in the United States, agencies like USGS and NOAA send data for situational awareness. This includes data for storm, temperature, earthquakes, wind, which can be used for emergency management. Modeling each of these features in GIS is pretty easy, but the challenge comes on how you can integrate it as real-time GIS data. The main reason being different devices, sensors, and feeds communicate on different protocols and different formats. So connecting to and receiving real-time GIS is essentially the first requirement of real-time GIS. So while it's easy to connect to a sensor and display it in near real time, the next thing that you might want to perform is to perform some additional processing and analysis as you receive the data. In this scenario, we are monitoring fishing vessels and detecting when they are inside a designated no fishing zone. As you can see here in the red polygon, the fishing vessels are seen in red icons. We're applying a filter that continuously filters events inside the no fishing boundary. So when an event is found to satisfy that filter, a new feature is added to that alert feature. These alerts are symbolized in red triangles. So if you see the vessels outside the red polygon, they are in green icons. So the second requirement of real-time GIS is the ability to perform continuous monitoring and processing of the data as you are receiving it. Here we have another example where we are trying to perform continuous analysis on real-time streaming data. In this scenario, we want to tell a parent when the child leaves the school property. As you can see, we are updating a child feature with the child's current location, at the same time detecting when the child is outside the school boundary. When the child leaves the school boundary, the parent is immediately notified via an email or maybe a text message that the child has left. Sending these kind of updates and alerts to those who need it and where they need it is essentially the third requirement of real-time GIS. Obviously, there are a lot of communities of interest, and they might be interested in these kind of updates. Hence, having the ability to send updates or route these events of interest to these different communities is really important. And it is equally important to send their updates to a particular channel. For example, it can be a mobile device, or it can be on an update on a map. So how can you get real-time data into ArcGIS? With GeoEvent, we have a wide variety of input connectors. As you can see here on the left, we have a bunch of out-of-the-box connectors, which includes polling an ArcGIS server for features, polling an external website for GeoJSON, JSON, or XML. You can also receive features, JSON or GeoJSON or XML on a REST endpoint or maybe a WebSocket. You can also receive text on a TCP UDP socket, or you can look for a folder in a conventional way for a flat file like CSV or GeoJSON or a JSON file. We also have connectors on Esri Gallery. These connectors include connectors for if you are listening to a messaging queue, like maybe ActiveMQ, RabbitMQ, MQTT, or Kafka. Connectors for social media, which includes Twitter and Instagram connector. NMEA 0183, which is a GPS standard. So let's say, for example, if you have a device which is communicating on that protocol, we can use this connector to bring the data into ArcGIS. CAP, which is a common alerting protocol, which is used for emergency management. We also have connectors for in-vehicle GPS, which is Sierra Wireless and Trimble. In addition to this, we also have a GTFS connector, which was released as a 10.5 release. We'll take a look at that in the first demo. In addition to these connectors, we also have connectors on Partner Gallery, which are developed to meet the specific requirement. So let's say if you want to bring data from your IoT devices, like Azure IoT or maybe Amazon IoT, or maybe if you are interested in AIS data, we have the Exact Earth connector. If you are interested in bringing the SCADA data, we have this OSIsoft and the Volam connector. If you are part of the Connected Citizens program from Waze, you can bring the Waze data feed for your city into ArcGIS through GeoEvent. We also have connectors for in-vehicle GPS devices like EnviroCar, Zoner, and CompassCom. If any of these connectors do not meet your requirement, you can create your own connector using the GeoEvent SDK available. And yeah, the connectors on the Esri gallery also have their source code, so you can also expand their capabilities. So how do you perform real-time actions? Similar to input connectors, we have output connectors. As you can see here on the left, we have a bunch of output connectors, out-of-the-box output connectors. The ability to add and update a feature, or pushing GeoJSON, JSON to an external website or WebSocket, sending text message, email, or an instant message, sending features to a stream service, which was introduced at 10.3. We also have a connector for adding and updating features to a spatiotemporal big data store, which was released at 10.4. You can also write to a CSV GeoJSON or a JSON file. We also have connectors on the Esri gallery. So let's say if you want to send some action to your Azure or IoT device or Amazon IoT device. Similar to input connectors for messaging queue, we have connectors for ActiveMQ, Kafka, MQTT, and RabbitMQ. You can also send a tweet through the Twitter connector. And similar to the input, we also have, you can also create your own connector if any of these connectors don't meet your requirement, or you may also want to extend the capabilities of the connectors on the Esri gallery. So how do you perform real-time analytics? GeoEvent Service is the answer, which essentially outlines the incoming data. This includes input and output and processors, or maybe filters. As you can see here in the slide, we have an input which is listening to a TCP socket. We have 4 outputs on the right-hand side. The first is feature service out. And between the inputs and the outputs, we have 3 filters. The first is speed monitoring filter, speed monitoring processor. The second is a dangerous area monitor. So let's say, for example, if your vehicle, or in this case, the ambulance is speeding, or if it is entering a dangerous zone, we can send a feature to alert feature service out. We've also configured a hospital proximity monitor processor. So let's say, for example, if your vehicle is in 5-minute drive time, you can send an update in the form of a text or an email. In this case, it can be that the ambulance is 5-minute drive time from the hospital. So the authorities will get a text or an email that the ambulance is arriving. Please prepare. So how do you work with real-time data? Let's take a look at the high-level features for bringing features come alive. The first step in this process is to create an input to connect to your live stream, or maybe real-time stream in this case. Next, you would like to create an output to send features to a stream service or maybe a feature service. Or it can be a wide variety of output connectors that I just showed. Once you have your input and output, you will also need to create or import your GeoEvent definition. Now, GeoEvent definition is essentially the schema of the underlying incoming data. It is that component of GeoEvent that tells what is the format of the incoming data. It includes attribute and data types. Once you have your input, your output, your GeoEvent definition in place, you need to create your input to your output. You need to connect your input to your output. And that can be done by publishing a GeoEvent service. Once you have a GeoEvent service, you can view your features getting updated in real time on a map. It can be ArcGIS Online, or it can be clients like Operations Dashboard for ArcGIS. So moving on to the first demo of this session, making features come alive. In this demo, we are going to see on how you can bring live feed from GTFS, which is the General Transit Feed Specification. It is a specification that lets you get the live status of the transit vehicles in your city. There are different feeds available across the world for different cities. And I think it's for free, but probably you need to check. We released this connector at the 10.5 release, and we'll proceed with the demo.
Okay, should be good. Just hit spacebar.
Playing?
Ready? Whenever you want.
All right, so to do this, we need to log into GeoEvent Manager. Now, GeoEvent Manager is very similar to ArcGIS Server Manager, where you can create your inputs, your outputs, your GeoEvent services, as well as you can perform administrative tasks like importing and exporting configuration, or you can even connect to different type of data stores, or maybe ArcGIS Online. So let's say if you have multiple departments in your organization and you want to connect to someone else's server in your organization, you can do through this. You can also create, import, edit, delete GeoEvent definition. So the first step in this demo is to create an input. So in this case, we're going to search the GTFS connector. And the GTFS connector essentially has 5 important properties. The main important one is the trigger interval and the time unit. By default, we have this link which connects to the city of Hartford in Connecticut. So you get to see the data from transit vehicles in the city of Hartford. So you can update this link with the link from your city. You can also update the trigger time and their units. Let's hover back to the monitor tab, and you can see that 226 events are being pushed. The refresh rate was 30 seconds. Let's take a look at the GeoEvent definition. The GTFS connector supports three GeoEvent definitions. In this case, we are going to use the GTFS RT vehicle. The GeoEvent definition has a wide variety of fields. As you can see here, entity ID, vehicle ID, bearing, which is the heading field. So the next step is to create an output. In this case, we are going to create an output for stream service. So we are going to create a stream service output connector. And we're going to select the GTFS RT vehicle GeoEvent definition. And we'll publish a GTFS RT vehicle stream service. And we're going to select vehicle ID as a display field name for the map. And this will publish a stream service, GTFS RT vehicle. And we'll save that service. Once you have your input and output in place, you need to create a GeoEvent service. So a GeoEvent service is essentially created using a model builder type experience. Here you can drag and drop your inputs, your outputs that you created. You can also configure filters and processors. I just dropped the input and output that I created. I'm going to configure a filter. And I'm interested only in the GeoEvent definition GTFS RT vehicle. So the same feed has data coming for different information, but I am interested only in GTFS RT vehicle feed. So I'll save that, configure and save that filter. And the connection is pretty easy, and you can publish a GeoEvent service. Once you have your GeoEvent service published, let's take a look at the stream service that I just published. We're going to take a look at the stream service. Give it a minute or so. As you can see out here, there are a wide variety of points on the map. And clicking on each one of this point, you'll see different fields. This is very specific to that particular city.
So I want to add one thing real quick, just for those of you that are interested in getting started with GeoEvent Server. This is a great connector to try and use. Sagar mentioned we just added it this week, but this service does come with a sample feed already built into it. So for those of you that are interested in trying this and you don't already have your own input types from maybe your own vehicles or your own fleet or whatever sensors you want, this is a great one to try because it's already going to come included with some of that sample feed.
So you can also, now these dots, this data also has the bearing information or the heading information. So you can also change the symbol to get to know the direction of that particular vehicle. So in this case, we are changing it to arrow and updating so that the bearing information can be taken into consideration. I'm increasing the symbol size. And rotating symbols, the field would be bearing. So with this, you get to know in which direction that vehicle, in this case it is the bus that is heading. So zooming in a little more further. You get to see that these vehicles are moving. You can also increase the refresh rate if you are interested to get more frequent updates. So that was about the first demo, making features come alive. Over to you, Josh.
Cool. Thanks, Sagar. So we're going to switch back over to the PowerPoint. Turn this on here. All right, you guys. So we're going to take a look a little bit deeper at applying some of the real-time analytics. So this is really I'd say the true value add of using the GeoEvent Server. Beyond just being able to pull in real-time data, it's to be able to take that data and provide some of the rich analytic capabilities that Esri has provided across our platform. But with real-time data, we want to be able to apply these kinds of analytics and filtering on the data while it's in transit. So we're not waiting until we've got a month's worth of data and we're going to go back and run some sort of analysis. We want to be able to do that on the fly, enrich it with additional information as we need to. We want to filter it down to just those aspects of the incoming feed that we're interested in. So we want to kind of dig a little deeper into what's coming through, and we want to make sure it's used in a way that's going to best fit whatever kind of output we're wanting to send it to. So this is done primarily in two different ways. The first one we're going to look at here is filtering. So filtering can be done based on either an attribute value, like I want this particular information coming through in a field, or we can do it on some sort of spatial property. So as you see here, we have 4 different examples listed. The first one is where we have, in green, we have some data coming in, which is showing some vehicle position information, and we're writing all of it out to a feature service so we can visualize it on a map. In that case, you're getting 2 different types of vehicles. That's why you see the 2 different colors, the blue and the orange. If we were going to apply a filter, we could apply a filter based on a field, which would show a vehicle type. So in this case, we have that incoming data coming through. We want to know, is it a snow plow? And by doing that, we're removing all of the additional types of data coming out. So this really lets you kind of hone in specifically what you're interested in looking at based on, in that case, an attribute value. Alternately, as I mentioned, you can do it based on some sort of spatial parameter. So if you have some stored geometry, which we call geofences, you can compare the incoming geometry of those vehicles compared to the geometry that we've stored. So in this case, we can say, is this vehicle inside of a dangerous area? Yes, it is. And in fact, you can combine both types of filtering. So in the last example, we say, is it a type snowplow, and is it inside of the area that we want to look at? So we're gonna switch over, and we're gonna show this demo as well, so you guys can see how that's configured and what this would look like on a web map once we have that in place. So let me see if I can get this set up here. Gotta get out of. Filter. All right, so we'll take a look at this. So in this case, I mentioned the feed that we're looking at here is actually a simulated feed of some vehicles coming through. This is going to include both two different types of data. It's going to have both plows and trucks in the data we're looking at. But we're going to spend the bulk of our time within the service itself, since Sagar showed how to configure the rest of the platform. So right now, what we have set up in here is 3 different types of filters. So if we kind of look from top left to top right, we have our plows coming in. Again, that's our the input source, and we're sending all of that out to this blue line over here to the top right, the all vehicles out. So we're basically writing the raw data out into a feature service, which is running on ArcGIS Online. ArcGIS Enterprise, and we'll go take a look at that service first. So you see here we have 5 different vehicles that we're monitoring. We have the red vehicles, which are of type pickup, and then we have blue vehicles, which are the snow plows. So by applying the filters, like we just showed in the earlier example, and this is a very simple filter, you're able to go in there and you're able to, there's a wizard interface where you can select how I want to configure these things. You don't have to know how to write the expressions out by hand. But by doing this, we're able to filter it down to just the vehicles that we're interested in. And we'll take a look at that, and you can kind of see how you would configure this if you were to build it yourself. And we do provide a sort of wizard interface, so it makes it easy to select the fields that you're interested in. You have a variety of operators that you can control. Is something inside? Is it outside? Is it occurring at the same time? So in this case, we want it to match that it's a of type snowplow. We can also put in Boolean operators. Is it greater than, less than? In this case, another example we're looking at here for alerting is off of speeding. And then we have one here where we're looking at something based on its geometry parameters. So each one of these is writing out to a service as well, so we can take a look here. Now I mentioned before we were doing, we had the concept of a geofence. So we were comparing the incoming vehicle based on some stored geometry. And in this case, we have one area that we've identified as an area of high risk. This is a particular canyon which these vehicles may potentially be operating near, which is a very high slope. So we wanted to be notified of when we have a vehicle entering this area, just for alerting conditions. So we can go back to the service. And again, this is writing out to a feature service called alert. And so when we add that layer onto the web map, you can see that we have 2 alerts that we've captured. We have one alert over here to the right, which is indicating that it's inside of that area that we're considering a high risk. And we have another alert. We'll look at this one first. And then we have another alert where we were monitoring earlier when a vehicle was speeding. So you see in this case, we were monitoring for any time we see speed above 45 miles per hour, we wanted to be notified of that. And in this case, you can see by the speed parameter there, it's listed as going 46. So we'd want to be alerted to that. So that's the end of the filtering, but we'll switch back over and we'll take a look at the processing side so you can see what's included with that as well. So on the processor side, we have a number of different kinds of geoprocessing capabilities that can be applied on the data while it's in transit. A couple of these we're going to look at in a moment are going to be the buffer creator. That's a very common one that allows you to take an incoming point, polyline, or polygon geometry, create some sort of buffer around that. So you could say, I want it to be a 1 mile buffer, or let's say we're following a stream and we want to create a 100-meter buffer around that stream. This is area you're concerned about erosion. We can change the geometry on the fly, so what it's going out to the output service is going to include that additional space you've put into it. Other examples include things like a geotagger. So if we have certain service areas that we're working in and out, when you have an input event that's inside one of those areas, you can tag it with the name of the service area that it's in. So you can basically do a spatial join on the fly with the data coming through. There's also ones that you can do very complex modifications to your geometry. One I really like on here is the difference creator. So this is a little more complex, but what it's going to do is it's going to, you basically start the day with a given polygon, and as events are captured throughout the day, it kind of erases sections of that within that. So take, for example, we have let's say I work for a police department, and this is my district that I'm concerned with, as I have cruisers, police officer vehicle driving through the town throughout the day. It's actually going to be erasing the areas out of that map where we've had coverage, where we've had an officer drive that day. So if you were to monitor this over a period of days or a period of weeks, you could see, wow, there's sections of our town that we never have an officer drive through. These are things that would be of concern that maybe as you're just going through a day-to-day operation, you would never pick up on these facts. But by being able to actually subtract the new geometry from whatever your initial service area is, you'll be able to kind of see these patterns that start to arise. We also have several processors available on the gallery. So these are things that were outside of our initial out-of-the-box product, but they serve certain specific tasks. So you can do things like a range fan. So this is really nice. So you have a point in geometry, and then you can set a view shed. How far can somebody see? What's their angle they can look at? A motion calculator, that's another great processor. By being able to take incoming point-based geometry, so if I know where something is, and I know when that point occurred, and then I have another point over here, and I know the time that point occurred, I can calculate all sorts of things. I can calculate speed. I can calculate how long it took to get from here to there. If I have elevation, I can take into account slope. I can figure out heading. I can figure out a lot of information from just knowing where a point was captured and when it was captured over a period of time, and you can create additional statistics that you can use and then enrich your services with later. So we're going to take a look at processing. So we're going to take a little bit further depth than what we did before with the filtering. So we're going to show that real quick. Come back out of here. Switch over to processing. So in this case, we're using the same inputs that we're using before. So we're still using that same plow input, but instead of using the filters that we had before, we're going to leave a couple of them, but we're going to kind of show you what can be done on the processing side instead. So again, as we see, we have the same kind of filter in place. Is it a snowplow? Because that's really what we're concerned with in this example. In my case, hey, it's great to know where the rest of my fleet is, but for all I'm really looking at is this one subset of the data. So again, we're taking that data in, we're filtering it based on a type of vehicle, we're writing it out to a feature service where we can see just the latest information of that. But the first thing we've changed is instead of having speeding as a filter, where we're just saying, is someone speeding, is someone not speeding, instead we've replaced that with an incident detector. So an incident detector works a lot like a filter, except the key difference with an incident detector is it actually has a duration capability. So again, with the example of speeding, if I'm monitoring a fleet of vehicles and a vehicle goes to quickly pass a truck, maybe they're going to speed for 2 or 3 seconds. That's fine. Well, it may not be fine depending on your use case, but at least you're notified that's the case. However, if I'm monitoring a fleet of vehicles and I see my particular driver has been speeding for the last 45 minutes, that's a different story. You'd like to know how long these things have been ongoing. So that's where the incident detector comes in, because with the incident detector, you can actually define opening and closing conditions, And in addition to having those opening and closing conditions, it will also store how long these things have been ongoing. So these are really, gives you a lot more power than just the raw filter. Okay, I think we'll speed it up here just a second so you can kind of see where that, actually open it up and you can look at it. Okay, great. So again, the actual configuration of it is very similar to what we had before, where we're still able to go into the filter, we're able to set an opening and closing condition, but there's a few additional parameters that are available through the incident detector. You can set a severity level. So if I have multiple incident detectors going in place, I could say, well, you know what, if somebody speeds and it's going on for, again, less than a few seconds, maybe that's just a notification. Maybe I just want to keep a record of it, but it's not something I'm as concerned with. If I see it happening for a longer period of time, that's a higher priority. Or in the example earlier of a vehicle entering a hazardous area, maybe that considers a more important, a more severe concern than just someone speeding. You can also set the geometry type for this as well, and you can set an expiration time. So by default, when a new feature's coming in, a new alert's coming in, it's going to close after 5 minutes. So let's say, I can use Sagar as an example. Sagar was driving a vehicle in an unsafe area. It's going to monitor how long he's been doing that, and then it will close. But if he's continuing to do that, let's say he spends the rest of the day doing that, I don't want to wait all day long to show that he's still driving there. So I can have it automatically expire after a given amount of time. So after 5 minutes, whether he's finished or not, go ahead and let's make sure we've documented that he's been doing this for at least a certain amount of time. Sorry to pick on you, but you know. So we'll speed this up ahead a little bit. The other thing we can do, there are two other types of processors that we want to look at. In addition to increasing the filtering, we can also do enrichment. So we can take incoming data and we can enrich it with other data in either a related table. In this case, we have some driver details coming from a feature service running on ArcGIS Online. So as we have that initial data came in, just had the type of vehicle and it identifying this is truck 1, truck 2, truck 3. I want to be able to actually supplement that with the name of my driver. Who's driving this vehicle today? What's his contact information? What's her email address? What's these other things that the information coming from that vehicle isn't going to have? So we want to enrich this on the fly. So what this creates would be an additional, in this case we're sending it to an email output. So since, as you see how these have connected, so if we go from top to kind of top left to bottom right, so we have data coming in from a snowplow, from lots of vehicles I should say, we're filtering it down to just snowplows, then we're detecting, you follow the arrows, then it's detecting vehicles that are speeding. So it's only those plows that are performing something we consider unsafe, and then only those vehicles that meet this certain speeding criteria do we then go down to the enrichment where we add the additional information about the driver, and then we send out some sort of email maybe to some sort of administrator who's overseeing this work. And the last example we have here at the bottom is with our buffer creator, and we talked about this before, so we could be creating actual buffers around the points as they're coming through. So I'm going to jump back over. I got a little bit more on that demo video there, but I want to jump back into the PowerPoint and kind of talk through a little bit more about what we're doing here. So when we're talking about geofencing, we mentioned that before for when we're enriching it, either enriching it based on the geometry or we're doing some sort of filtering against the geometry. We have several types of spatial operators that we can perform against this data. We can monitor when something is inside or outside. We can also monitor when someone entered or exited. So instead of being constantly notified that, yes, you're inside California, yes, you're inside California, we could get a notification of, you have entered California. And then once you've left, we get another notification, instead of every 30 seconds sending the same information repeatedly. And there's several of these operators we can choose from. And so this kind of pulls back on maybe some of your geography background for when you'd want to use one versus the other. We also have some really good help that'll show you when do I want to use contains versus inside versus within. Some of these kind of deal with the spatial operator. Is it completely enclose it versus is it crossing and intersecting? So just a couple examples here. So when we put all this together, We want to kind of show you a couple examples here of how all these pieces can come together. What we're looking at here is an example of a storm that's being monitored off the coast of North Carolina, and we're comparing the geometry of that incoming storm versus against a ground station, which was marked there in that little yellow diagram. We'll let this play through again here in a second. But what's happening is we have it monitoring, so when that storm that we're monitoring crosses over that ground station, we want it to be alerted to that. So what it showed in there bottom right a moment ago is it actually sent an email output that says, some sort of hazardous condition has occurred in this area. Here's a link where you can go look at this web map and see the additional information. So the point being that, I know we've mentioned a lot about vehicles this morning, but the technology is certainly not limited to tracking vehicles. It can be any sort of moving object. It can also be objects that aren't moving at all. It's just a sensor that's constantly sending updating information. So again, on the geofencing side, we can also do any or all, so we can control whether something is occurring within all of the possible geofences that we have, or if it's only within a few, or if it's disjoining these. So you can kind of see an example of what that means versus the any and all here. So of course, any means the point I'm monitoring is inside just one of those or any of those potential ones, versus all, meaning of course there has to be some area where they'd be overlapping. So this is kind of a use case you can see kind of simulating what we were looking at here earlier with the plows and different kinds of notifications. So if you see, we just got a little blue dot here on the screen that indicates that one of these bulldozers went from one zone to another. Not a huge important thing, but something you'd certainly like to be monitoring, that some of your equipment is moving from one zone to another. However, when you see we got that little bright red, bright orange notification here, we just got notified somebody drove some of our equipment off of one of our sites. That's something you'd probably be concerned with, someone taking your equipment away. So these are the kinds of notifications that can also be triggered within GeoEvent. So one of the other things that is really important with being able to have real-time data is visualizing this information. There are two primary ways of visualizing real-time data. The first is that you're able to subscribe to a stream layer. This is the example that Sagar showed earlier with the bus data coming through. And what this is doing is this is GeoEvent Server writing directly to it's actually pushing data directly to a client application. Now, in this case, there is no database. There's no data stored on the back end. But it's a very lightweight service that clients in a web browser and a mobile application, they can see some features either moving in real time or updating in real time as quickly as possible. But again, there's no archival side of this because there is no data storage. If you're wanting to do data storage, then you need to use a polling option where one of your client applications would be polling a feature service or a map service that's backed by an enterprise, either an enterprise geodatabase or what we've introduced at the beginning at the 10.4 release last year is the spatiotemporal big data store. This is our big data solution for being able to consume and visualize large volumes of real-time data. When you see this in place, and I think Sagar showed an example of this earlier on, the kind of summarizing how this visualization works, you're able to take all those different data feeds coming in through the GeoEvent server. You can store those out through your spatiotemporal big data store, which provides some additional map and feature service capabilities. All of this, of course, falling within the ArcGIS Enterprise, which can be visualized through all of your mobile clients on that. So we will start to wrap up. I want to give a little bit more of a summary of kind of where this whole picture comes into place. So what we're looking at here, of course, is the ArcGIS Enterprise is truly this fully formed mapping and analytic platform. And by that, what we mean is that we're able to take in real-time data, bring it in through the ArcGIS Enterprise. We're able to perform the analytics on the fly. We're able to then store that in a way that can be used to the rest of the ArcGIS Enterprise system. The benefit of being able to use the GeoEvent server is that we're going to simplify this process. We're not going to require that you be a developer, write your own connectors to be able to consume some of the standard data types. We do provide that capability for users that are wanting to be able to expand our out-of-the-box functionality. But we really want to try and make it as easy as possible for people to be able to consume some of that information coming through. Again, we are doing the continuous analytics, so we're not waiting until after. We want to be able to, if you notice some sort of either hazardous condition while the data is coming through, we want to be able to act on it. We want to be able to enrich that information while it's in flow. There are some additional visualization capabilities for some of our really large data options, which we can talk about. We have some other sessions this week that'll really get into that. But wanted to kind of give you some guidelines as well. These are some, there's a link on here where you can get some additional information about we have a GeoNet forum where you can communicate with the rest of the community in the real-time community. We also have on our GeoEvent gallery, we have several tutorials that will walk you step by step, everything that we did today, and several more sessions to be able to walk you through that process. We also have video recordings of all of our technical workshops from our previous sessions at Dev Summit, and also we'll be having additional sessions here this week that will also be recorded and released within the next coming weeks. I'd like to draw attention to a few of our other sessions we have going this week. For those of you that are wanting to get a little deeper dive into a particular aspect of real-time capabilities, whether that be getting deeper into some of the analytics, or if you're looking at massive scale, I want to look at some really big data visualization and consumption options. One I really would like to focus on for those of you that are interested is for Thursday morning, we have our Internet of Things presentation. This is a completely new session from anything we've done in the past. In years past, when we've done our IoT sessions for Esri, that typically means we're bringing lots of toys out, little electronic gadgets, and we're showing how we can connect everything. This year we're changing it up, so we're done playing, so to speak, and we're really showing how we can take IoT into a real-world business application. We have several examples of data feeds that we're bringing in from Azure, the Azure IoT Hub. And so that should be some really exciting stuff for people that want to kind of see the next front edge of real-time capabilities. We do have the survey available within the events app. So for those of you that enjoyed today's sessions, hated it, any additional feedback you have from us, please fill that out. Helps us improve the sessions for future audiences. And with that, I will open it up to questions and feedback for anyone? Up in the back, sir.
So I watched you set up the filter by connecting the input, the filter to the output in a visual way, which was very nice, very easy. Is there like a programmatic way, or is there a way to script that so that it can be done through a script instead of through the visual part? So the question was, part of our demo was setting up the inputs and outputs through the service designer so that we're able to, from a kind of a graphical user interface, configure these settings. But how can you do that programmatically? So one of the things we released with the 10.5 release was we swaggerized our API. So for people that are familiar with that, it allows you to programmatically get into our REST API that's behind the scenes. Every single thing that we're doing within that interface, if you you can open up a web debugger, you can see exactly what we do. Also through the Swagger interface, it gives you detailed steps on how to configure all of these things from the REST API. So it certainly simplifies the process of being able to programmatically do it. And in fact, there's several additional capabilities available programmatically that even at this point aren't available through the user interface. One of them, which is things that are going to be coming at 10.6, is being able to start and stop all of your inputs at the same time. So if you need to do some maintenance on it, you can do that easily through the API, but we don't yet have a way to expose that through the interface. So there's exciting stuff on that for you. So, yes?
Yeah, actually a similar question like the previous one. Okay, right now my agency have working on the 10.4 GeoEvent Server. We create tons of input, output, and monitor service. Right now we're trying to move it to the 10.5. Then we got a problem. Okay, so since we need to manually kind of move things. Is there any kind of way you can export out the input to the export the older kind of on the 10.4 and the input to the 10.5?
So the question was migrating from 10.4 to 10.5, what's the easiest way to configure that? So one of the really nice things about the GeoEvent server is it provides an option to export your configuration on the fly. And you can go within the within the GeoEvent Manager, if you go to the Site tab, there's an option for configuration. You can export it out, and it'll export it to an XML file, which can then, if you go and upgrade to a 10.5 environment, you could even do a completely new environment, completely clean environment, import that configuration XML, and it'll deploy everything for you again. Now, one thing we added with the 10.5 release, which is great from a data recovery situation, is we've now set up automatic backups for you. So by default, once a day, it's going to create a copy of that XML file for you. So if you get a call and you come into work tomorrow and find out all of my site's gone, something broke, you still have a backup of yesterday's configuration, or as of midnight, without you ever having to set it up. It's going to automatically export that configuration every day for you. And of course, you can configure it to do more frequently, as you like. So, additional questions? Yes?
I just have one about the geofences. Are they dynamic? Can you have a dynamic geofence?
They can be. So you have two options for geofences. Geofences are, he was questioning again whether or not geofences can be dynamic or if they're simply static geometry. A geofence for us is, just a little extra background on that, a geofence is the geometry that's stored in memory. So these for very fast option. The way I was showing it was with static geometry, where I manually imported it one time. But you also have the option of doing a geofence synchronization, where you can set a certain, so often, every 5 minutes, every 10 minutes, every 30 seconds, whatever the case may be, it will go out and poll against these features, and we'll pull them back in. So an example you saw with the storm front that was moving, that's actually a geofence that was moving. And you can configure that to update throughout the day. You can also put settings on there, certain time values. So not only is it updating throughout the day, but it's only valid for these hours. So for example, of like a bus route. Well, this route is only applicable in the morning. So you can bring it in, but it doesn't even apply unless it's a certain time window. So that's options. So you're going to grab some?
Yeah, sure. You go ahead.
Where do we find you downstairs?
So the question was, yeah, you can find us on the real-time island, real-time island. Yeah, just in case for you guys, if your coworkers have missed this session is recorded and will be uploaded on YouTube in coming weeks. So you can also take a look out there. All right, that was next. Yep.
So I'm assuming with the geofences and things, you can also set up filtering that tells you approaching distances.
What you would have to set up in that case is you would take your geofence and you would actually have a buffer around your geofence, so that you're once you've hit that buffer around that. Right now we don't have an approaching.
So the storm thing had a buffer around it. So
Could you not calculate the distance from a known static buffer?
Yes, if you did, you could create that around that point and then be notified when it's approaching. So I forgot to answer the question, but asking, could you create could you notify when something is approaching it? And so an example of that we see quite often is, say, hospitals. So if you're monitoring ambulance feed, when a hospital has a buffer, so once an ambulance is 5 minutes out and approaching, we want to set up some sort of notification to alert the ER staff that a vehicle is incoming. They'll be here within 5 minutes. So it's not just notifying them that they're there, but you can actually create a series of these rings, either using buffers like I did, which was just a round circle, or you could actually do real drive time mapping on that as well. We do have a drive time processor which will let you take your own network analyst data set and create more realistic buffers that are based on drive time or drive distances. So. Yep. We'll come back with you next. So.
Can you detect events of like the changes to a database? Like adding a new record, it might be a new feature or something, or change to an existing record?
So the question is, could you monitor in a database for changes with new records added? So we're not able to read directly into a database. What we are able to read through is if you have a feature service running off a database, we can detect when new features are added. So that's typically used in conjunction with some of our mobile applications, such as Collector. So if I have someone in the field that's doing inspections, they they put in a new record. I did some inspection on this lamp post or whatever, took some pictures, submitted it. We are monitoring that we've seen some new records coming in, and we will pull that as soon as it's created. So we are able to do that, but the only requirement is it has to be based on, there has to be a feature or a map service running off of that database. We're not able to put a hook in directly to a SQL Server or Oracle database directly. So the 9% would come back.
So if I've got a weather station that's pumping out wind direction, speed, temperature, humidity, that sort of stuff, it's not moving, so I don't want to write a new feature for every time it changes. Can I write to a related table?
Yes.
Or just a static table and not a point quotation?
So the question was, if you have sensor data coming in from a weather station where the station itself isn't moving, but you have updated data throughout the day, can you write to that without having to create a new feature every time? You just want to update those parameters. And that's a very common workflow that we can do. You can either do like the example we showed earlier where you're updating the feature, where you would actually it'd be the same object ID, but you're sending out all of the details again, you're sending out the geometry again, you're sending out all the features again. That's certainly one option. The other option is you can only send those fields that you're interested in. So you wouldn't necessarily be writing to a related table, but if you had, say for example, I had a temperature sensor or weather station data coming through. I may not have any geometry. That sensor may not know anything about where it is, but I have all that geometry in another related table. I can join those on the fly so that then my output has both, or I can choose to just update those fields into a feature service that already has functional geometry. So you really have two options.
So if I wanted to do an ongoing log, not just an update.
Right. If you want to do an ongoing log, you could still choose to do either option. I want to have all the geometry. If I have geometry in this table and I have just sensor data, I can merge them, write them out together into a CSV log or something like that. Or you could have a feature service that has both, and I just want to change the current values, but not change the geometry. You can do that as well.
So we have an option called as related feature service. For example, geometry coming from a feature service and data feed coming from a stream service. So while you publish stream service, you also have an option of what is the related feature service. So you can bind them together and ensure that the geometry comes from the feature service. And on the map, you can see that, okay, this sensor is in Hartford and its value is getting updated. That's what. So this is a very common workflow.
You were next, and then we'll get you after that.
Yeah, so my organization is using Python script to consume weather data in wind speed and wind direction. But this comes in like 24 different arrays. So is there a way in GeoEvent that we can consume that without having to create 24 different fields in our schema? Because that's essentially what was happening. We had the field map from that JSON from the REST service. So arrays 0 through 23 for each hour. So we just want to be able to consume all that weather data into the schema in one field, one speed, one direction. How can that be done in the GeoEvent server?
So let me make sure I'm phrasing the question right. So you're bringing in sensor data, but you have, in this case, you said 24 different schemas you're working against, right?
Oh, no, it's one schema.
One schema.
The time could be any time from 0 to 2359. So that means that there's 23 arrays, but we have one schema for the time and one speed and one direction for that time of each individual feature. So just think of it as each feature has one time, one unique time, one speed, and one direction for any given random time.
Yeah, I think we'd have to look at the use case in that case a little more specifically with you, maybe one-on-one, to see which would be best to do. For that kind of question, I'd probably recommend coming down to the real-time island and kind of, if you have a laptop, if you can show them what the data looks like, that's great. Take 5-10 minutes and say, okay, how would we actually process this to get it into a usable example? But yeah, sure. Sorry, it's hard to conceptualize some of the questions. And then we'll get you next.
The sensors are running to AWS at the moment, AWS Online. Is there any disadvantage of going to AWS, then to the GeoEvent processor, or you change the sensors to go straight to the GeoEvent processor? Or it doesn't matter?
Shouldn't matter if you see a delay. The question was, currently they have data flowing to AWS, so the Amazon Web Service, and then to GeoEvent, or does it make more sense just to go straight to GeoEvent? I think the only exceptions would be if you were trying to do some sort of like like batch work. You know, I'm waiting until I get 100 records on AWS before I send it. We don't recommend that. With GeoEvent, it's much happier to get data as it's coming through. So if you're seeing some sort of significant delay or some compiling that's occurring on the Amazon side, then I would say go straight to GeoEvent. But otherwise, no, we actually have connectors both for the Amazon, we have for the Amazon IoT Hub and the Azure IoT Hub. We have connectors that can read directly from that if you're using either their event hub setups, or you can just consume directly from that. One of the actual benefits of going through those, something like an AWS or Azure first, is those platforms can also provide, if you're getting sensors from, you're getting data from lots of sensors, they can provide device management, which is something we don't provide. So potentially they can serve as a gateway that's aggregating all of your sensors together. Let them worry about bringing them all in, and then we'll take that consolidated feed. So it can work. It can actually work in your benefit when we complement it, as opposed to try and take over something like that. So I think there's two over here. So we'll get you, and then.
No, there was a guy.
Oh, I'm sorry.
Yeah. Sure, go ahead.
I'm just curious, so this is obviously reading the data that's coming in. Is there a product that this pairs up with where you can dispatch the data in when it comes? For instance, a job pops up, you want to send something.
Okay, so this use case is pretty common in case of telecom industry. For example, if one tower fails, how do you get to know? So yes. We do have certain, I guess, customers who have done this thing, wherein, you can, but I think you need to use this in tandem with some, I guess, collector, yeah.
Well, we do have an application called, that we have some workforce application, Workforce Manager, that's actually designed exclusively for those kinds of scenarios where I want to send something gets, we got a new service call comes in, I want to see who of my staff is available, who's not currently on a call, I can route them to that. So we have some very focused mobile applications that are designed explicitly for that. GeoEvent is more of the, I want to perform analytics on the data while it's coming in. It's not just simply a staffing or a routing or alerting. We want to be able to actually analyze the data coming through, look for patterns on things. We do provide that notification, but we want to perform a little deeper dive than just, routing. So.
Just attending the open data session earlier, if I federate some external service, can I run this event monitor against federated services as well?
Federated map and feature services? Yes, sir. Mm-hmm. Yep. So that way the question was, if he's using a federated service, can he use those sources? So yes, absolutely. We can connect to anything. The ArcGIS Enterprise we're fully a part of that, so we're able to connect to all services that are run through that.
My question is about setting up this GeoEvent server. Do we need a separate server, dedicated server for this, or we can install it on ArcGIS on one machine?
GeoEvent. Okay, so the question is, do you need to have a separate server for GeoEvent? It is recommended to have your real-time server to be separate because of RAM specification. All these real-time analytics, the recommended RAM is 16 gigs. So it is recommended to keep it separate. We do have a best practices session on Thursday in the app.
It's Thursday from 10:15 to 11:30 is our best practices session. That will talk you through the different architecture recommendations for how best to deploy this. So if it's something you're interested in, sadly it is the same time as our IoT session, but we are recording everything. So if you don't get to see whichever one you choose to go to, pick the IoT one because I'm presenting that one. But if you do pick the IoT one, as you should, you can always go back and watch the best practices later when you're actually back in your office and trying to set this stuff up. So. Typically, within a few weeks, they'll have them available. There was a link on here where those are typically made available through.
Yeah, it's on Esri event channel on YouTube.
Typically, they do, the plenary is usually some of the first ones they get up, and then the technical sessions they kind of trickle in over the next several weeks. Demo sessions do not get recorded, but all the technical sessions do. So if you've gone to some of the stuff down in the expo, those sessions are not made available. Any additional questions? We've got a few more minutes.
Okay.
Sure, why not? That's why we're here.
Performance, okay?
Mhm.
So right now, it's, because we're talking about a lot of kind of scenarios. So what exactly? Because we have maybe more than 1,000 air quality monitoring sensors or something. So, and we kind of Northern California, Southern California. So can just one GeoEvent server handle this kind of thing, or we need a separate kind of GeoEvent server?
So GeoEvent's question was basically about throughput for GeoEvent. How much can a single GeoEvent server handle per second? So the GeoEvent server is benchmarked at bringing in a single GeoEvent server can bring in up to 4,000 events per second. I do want to preface this by saying that is straight message in, message out. As you start to add additional processing, that's going to slow that down. The other thing to keep in mind is depending on what kind of input and what kind of output you're using, those numbers can be reduced even more significantly. So I mentioned in here about the spatial deployed big data store. That's our big data store solution. One of the key benefits of that is we're actually able to write to the spatial data store at about 100,000 events a second, which is pretty good. However, if you were not using that and you were using a more traditional enterprise geodatabase system like Oracle or SQL Server, that 100,000 goes down to about 100. 150, not 1,000. I'm talking like 100 events a second, 150 events a second. So.
Different kind of sensors. So this means that we have a different kind of definition. So we kind of a lot of kind of process kind of redefine the input based on different type of sensor. So we do have a kind of array of kind of process. Okay, kind of mapping, kind of the field. Okay, for different because the different sensors have a different kind of the input field. We need to kind of remap kind of the process to become a single standard kind of. The output format stored in the spatial temporal database current our situation. Right now, we probably only have 100 sensors, kind of look good, but I don't know when we scale up what happens.
Yeah, I mean, and those are certainly concerns that, when you're looking at scaling up, when you're going from a small scale deployment to let's go to full production, the best case I can say, best recommendation is really to try it as you go along. I think for most people in production, by the time they've put in, and this is of course subjective, but by the time they're actually putting in, the processing they want, they're putting in the kind of filtering, comparing it with geofences, they're probably getting somewhere in the maybe 1,000 to 2,000 events a second. If you got if it's a lighter weight service, I'm just bringing stuff in, you'll hit that upper limit, no problem. If you really can put a lot of stuff in there, we've seen those numbers drag down. But it's going to vary from deployment to deployment, so you just have to kind of start working your way through it and play with it. So
that is why it is highly recommended to keep GeoEvent server on a separate machine, because in future, if the data rate or maybe geofences or something goes on the upper bound, probably instead of hitting on the performance, it's good to have a separate server, especially when you are using spatial temporal big data store. That also uses it is recommended to have 16 gigs for spatial temporal data store also. So probably there will be a conflict. Both the applications will try to compete for resources, and what will happen is real-time GIS, it doesn't meet the purpose of what real-time GIS is, because both the applications are resource hungry, and when you are using geofencing, it is all in-memory processing, so everything gets cached into RAM, and even for spatial temporal data store also, your recent queries get cached into the RAM to increase to improve the query timing, response to the queries. So yeah.
Any other questions?
Sure.
It's always nice to ask. And the reason I ask, and part of the reasons why in this seminar, we try to wrap up early to give time to let these questions. There's always, as is always the case, there's a big mass. I say, any questions? Everyone says no, and then it's like, then everybody comes up. Actually, I do have a question. I just don't, it's like, we'd rather ask it now and let it out there, and, we'll still be available for a few minutes afterwards, though, anyway. But
so our vehicle data is streamed to text files. They're continuing to build it. Can this reach into those text files and pull out the data as it's coming in?
Yeah, so the question was, can you read GPS data or vehicle data coming from a text file? Yes, we do have a connector for reading data from a CSV file or JSON or GeoJSON file. It was a conventional way to read data, but it is highly recommended to have it on some kind of REST endpoint, because over a period of time, you may have some garbage files in that folder, probably a file lock because of a lock being held by a particular process, right? So it is recommended to have it on REST endpoint, but if the customer or the client requirement has it on CSV file, yes, it works. Yeah, there are so many applications across the world who still work on the legacy systems, and I guess
And it's a very common. It is a very common production workflow, because the connector will actually watch the folder for new files. So as new files get dropped in there, it'll read them, and then you can configure it to delete the file immediately afterwards. But as Sagar says, you're always going to have some that just kind of don't delete, and it just so you have to monitor it.
These files are actually being continually written too, so they're building.
So we do, this application is pretty common. One is you have n number of files building up in that folder, and the other application is the same file getting updated n number of times. So we do have a custom connector that was developed by one of our coworker for the second application that I told you. That file grows larger and larger, kind of. You can stop by the real-time island and we can share more information on that. But a more common use case is same folder has number of files getting built up, like one file for each day, and every time you have a newer file, again that has a compromise that if that file is taking lot of time to write, this thread is going to look into that folder for a newer file. The moment it finds a newer file, it's going to read the data. But let's say, for example, in an instance where the entire data is not written, the process is not going to read the entire data. I mean, it's kind of like a timing issue. Say, for example, if it's a large file getting written, by the time the file is updated, this process is already reading the data. Yep. But yeah, definitely you can stop by for at our island. Okay.
All right. Well, thank you, folks. We appreciate it.
Thank you, everyone.